Let's look at this problem. The uniform 10 kilogram ladder and this figure, look at this ladder. It's the stairs that you are going, this is the wall. It's not shown very clearly here. This is point B and this is the length of the ladder and this is the angle and this is the floor. So A and B and it's 4 meter. So the uniform 10 kilograms. So this ladder has a weight of 10, a mass 10 kilogram. You have to multiply this by 9.81 to make it in Newton. Ladder rest against a smooth wall. So this wall has a smoothness. There's no friction at this wall. It's smooth. So friction here, there's no friction force, but of course there's a normal force, but there's no friction force. So it's a smooth wall at B. And at the end A rests on a rough here, rough horizontal plane. So here A, there is a friction force and of course there's normal force. Here, whether it's smooth or rough, you will have a normal force, but there's no friction force because it's smooth. Here, because it's friction and there's a rough surface, you'll have a friction force and you'll have a normal force. So it's a rough horizontal plane for which the coefficient of static friction is mu s 0.3. So the mu s here is 0.3. Determine the angle of inclination theta of the ladder and the normal reaction at B. So he wants the angle theta and he wants the normal reaction at B if the ladder is on verge of slipping. So at slipping, what is the angle theta? Let's look at this like that. Let's try to do the forces and try to determine theta and NC. Of course, this is the stairs. Again, I said here is smooth, so there's normal force only. There's no friction force. And the mass of this ladder is 10 kilograms, so 10 times 9.81 to make it in Newton. And always the weight should be at the center. He said that this is 4 meter. So this is 2 and this is 2. So I'm going to make it in the center of the ladder, 2 meter from here and 2 meter from here. This is the angle, and remember A, there is friction here, so there is friction force Fa, because if this ladder gonna go that way, so the friction gonna be the opposite, friction force that way, to the right, and there's a normal force A. This is the angle theta A. Okay, he want to know the friction force at B, and he want to know the normal force at B, and he want to know the angle theta. Now let's do it like this. This is 4 meter and you have the angle, so 4 cosine theta, so this is 4 cosine theta, and 4 sine theta, this is 4 sine theta. So we have this y-axis dimension and we have this x-axis dimension. Let's find summation of force at the x. Summation of the forces at the x, you have friction force Fa going toward the right, the positive. This is y, and you have this normal force toward the negative. So minus mb, normal force in the b direction, the negative, and Fa, friction force Fa for A, equal to 0. Now this is equation 1 because these are two unknowns. Let's do summation of forces at the y equal to 0. You have Na going plus, and you have this one going down. This is x, so you have this and this, positive, negative. So Na minus 98.1 equal to 0. Now Na is equal to 98.1. Now we solve for Na. So we solve for Na, we have to find out, since here the friction force Fa could be found from what? Mu times n. This is by default. The friction force Fa is equal mu times Na. So mu times Na. Mu is given. He told you mu is 0.3 in the example note. 0.3. So mu is 0.3 and the normal force is of A, of course, of A is given here, 98.1. So 0.3 times 98.1, you would give 29.43 Newton. Now we found the force Fa. Now remember here, we know the force Fa. We could find the normal P. So normal P from equation 1 You could find it because the MP is equal FA, because if you put this on the other side, it's going to be plus. So MB is equal to FA. So whatever FA, 29.43, normal force at point B is 29.43. Now let's find the angle. What other equation? Faisal, in static you have summation of force at x equal to 0, summation of force at y equal to 0. The other equation, the third one, is summation of moment equal to 0. Which point you're going to take here so you could take a lot of forces out? You remember here there is one force, one force. So it's good to take summation of moment at A equal to 0 so to cancel out FA and NA, to not put these two into the calculation. So take summation of moment at A. So summation of moment at A equal to 0. There is two forces here. Moment at this point, again, cancel this and this. You take this, make a nail here. This force will rotate in the negative. So minus 10 times 9.81 times the distance from here to here. This is 4 cosine theta. Half of it is 2 cosine theta. So minus 10, 9.81, 2 cosine theta. And this force, if you make a nail like this is going to go like this. A positive. MB times 4 sine theta. Plus NB 4 sine theta. Remember MB, we found it here, 29.43. So this is known. The only thing that's unknown is sine theta and cosine theta. You could play with this equation. Just take this side, the other side to make it plus. So make it like this and take that and leave the other side. So you divide sine over cosine, you'll have tan theta, and you put this on top of this, you'll get 1.667. So what's tan inverse of this? Theta is equal to 59. So that's what needed. He needed the normal force at point B, and he needed the angle 59. That's the answer to this question.